It's back, glowing like a sapphire ember against the darkness of space. After vanishing behind the sun for weeks, the interstellar enigma known as 3I/Atlas has returned. But this time, it's not just visible, it's blazing with a strange electric blue light, brighter and hotter looking than our own sun. Scientists expected it to reflect sunlight like any other comet or asteroid, but what they found instead defies every rule in the book. It's not reflecting light, it's emitting it, glowing with an intensity that suggests something even hotter than the sun's own 5,800 Kelvin surface. And now, Harvard astrophysicist Avi Loeb has added this to the growing list of impossibilities, the 10th one to be exact, surrounding an object that by all logic shouldn't exist at all. Think about this. 3I/Atlas follows a path almost perfectly aligned with the ecliptic plane, the very same path our planets take around the sun. Yet its behavior screams alien in every sense of the word. 10 statistical anomalies, all wrapped in one impossible traveler from the stars. What you're about to hear isn't just another cosmic curiosity, it's the kind of discovery that forces scientists to rethink what's even possible. And it all begins with that eerie blue glow, a color that hints at technology, or at least physics, we've never encountered before. December 19th, mark that date. It's being called the moment of truth. Most of us learned in school that comets shine because they reflect sunlight. Simple, right? But what if one shines brighter than the star it's orbiting? That's the puzzle scientists now face. Every new piece of data has brought another contradiction, each one chipping away at the comfort of conventional explanations. If you're feeling a chill run down your spine, you're not alone. Even the experts admit they're baffled. Early reports this morning confirmed something no one saw coming. 3I/Atlas didn't just get brighter, it flared up, far brighter than predicted, and its light turned deep blue. Normally, dust surrounding a comet makes it appear redder. So how is it glowing bluer than the sun itself? On October 29, 2025, it swung by its closest approach, perihelion, a mere 54 million kilometers from the sun, where over 770 watts of solar radiation per square meter should have blasted its surface apart. Any normal comet would have disintegrated under that heat, but not this one. Instead, it stayed intact and invisible. For a while, Earth-based telescopes couldn't see a thing. 3I/Atlas had slipped behind the sun on October 21st, hidden in its blinding glare, out of view during solar conjunction. The timing couldn't have been worse. It passed its closest point to the sun just yesterday, while Earth sat helplessly on the opposite side of the star. If that sounds suspiciously convenient, well, some scientists have quietly wondered the same thing. Was this coincidence or something more deliberate, a sign of intelligent design? Luckily, space-based observatories had front-row seats. Stereo A, orbiting slightly ahead of Earth, captured its first glimpses with the Core 2 coronagraph. Meanwhile, SOHO, stationed perfectly between Earth and the Sun, kept its LASCO instruments trained on the object, recording data without interruption. And from high above Earth's atmosphere, the new GOES-19 satellite, launched in 2024, added its own eye in the sky, its CSOR-1 coronagraph, resolving details our ground telescopes could only dream of. Together, these three perspectives painted a picture unlike anything ever seen before. GOES-19 CSOR-1 even detected a luminous halo spreading 300,000 kilometers around the object, almost the distance from Earth to the Moon. Imagine a glowing sphere of light that vast, hanging in the void. Back in August, scientists detected a plume of carbon dioxide expanding at the same scale, but the cause of that enormous energy release, still a mystery. Sure, comets brighten as they near the sun, but this was off the charts. And then came the clincher. the color measurement that changed everything. Both the LASCO and CCOR1 coronagraphs independently confirmed the impossible. 3I/Atlas is bluer than the sun. Loeb didn't mince words. Extremely surprising, he called it. Normally, dust scatters sunlight toward the red end of the spectrum. Cooler surfaces emit longer, redder wavelengths. Yet this object, which should have been faint and reddish, now glows in vivid blue. Each new observation only deepens the mystery, and what began as a cometary curiosity is quickly becoming something else entirely, perhaps the most tantalizing cosmic riddle of our time. At its closest brush with the sun, perihelion, something extraordinary happened. 3I/Atlas shifted into an even deeper blue. Hidden in the coronagraph data lies a clue that traditional comet science simply cannot digest. Blue light means heat, immense, blistering heat, the kind that suggests not just reflection, but generation. And that's what has Harvard's A.V. Loeb asking the question few scientists dare to say aloud. Is 3I/Atlas powered by something hotter than the sun itself? Let that sink in. If more energy is leaving this object than it receives from the sun, then something inside it is producing power. And that, Loeb argues, could only mean intelligence. Because if sunlight and dust can't explain the color, then we're left with one possibility. It's generating its own energy. But that shouldn't be possible. No natural object carries fuel that burns hotter than a star's surface. So either our laws of thermodynamics are fundamentally flawed, or we're witnessing technology.
On possibilities. And I think it's inappropriate, especially in the case of alien technology, because it could be a black swan event. It could be something that affects the future of humanity, and if we behave, very conservatively, we might not last very long.
This 10th anomaly is the final thread in a web of impossibilities. And as each thread tightens, it's strangling every conventional explanation we've ever used to describe the universe. So let's pull the curtain back on what shouldn't exist, but somehow does. First, there's the trajectory. 3I/Atlas arrived aligned within just 5 degrees of the ecliptic, the thin plane in which every planet orbits the sun. Interstellar visitors aren't supposed to do that. They come in from random angles, above, below, from the galactic wilds. The odds of one arriving on that exact plane by chance? 0.2%, like tossing a dart in pitch darkness and hitting the bullseye. Then came July and August, when telescopes caught something even stranger. 3I/Atlas fired a jet of material aimed directly toward the sun. Every comet we've ever studied does the opposite. Their tails are pushed away from the sun by radiation pressure. But this one, it broke the rule completely, shooting gas and dust toward the heat source, like someone running headlong into a storm. And it gets wilder. This isn't some tiny rock. 3I/Atlas is 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov, yet it's moving faster than either of them. Imagine a fully loaded cargo ship outpacing speedboats. Impossible, right? In physics, the heavier an object is, the slower it should move after a gravitational slingshot. But 3I/Atlas doesn't obey that. It's rewriting the relationship between mass, velocity, and motion. Now consider its timing, a cosmic performance too precise to be chance. The object passed near Mars, Venus, and Jupiter in near-perfect sequence, yet managed to stay hidden from Earth during the most crucial period, perihelion, the one window where we could have seen the truth. Picture a tourist visiting every landmark in a city while somehow avoiding every surveillance camera at the airport. The odds? astronomical. Then came the composition shocker. Spectroscopic scans revealed a nickel-to-iron ratio identical to industrial alloys, the kind forged in terrestrial foundries, not drifting around in space dust. Comets are supposed to be mostly ice, dirty snowballs, 80 to 90% frozen water. But this? 3I/Atlas contains only 4% water, making it drier than the Atacama Desert. It's not a snowball at all. It's a metallic iceberg. And when scientists measured how its light scattered, the polarization, the fingerprint didn't match anything in the known cosmic catalog. Not even Borisov, the only confirmed interstellar comet. Whatever this thing is, it's unique. Entirely alien in material, structure, and behavior. Here's where everything starts to converge. The same region of space that sent us the mysterious WOW signal in 1977, that one unexplained burst of radio energy that's haunted astronomers for decades, is the exact origin point from which 3I/Atlas came. 48 years apart, two arrows fired from the same direction, hitting the same cosmic target.
And now, with its blue-shifted glow at perihelion, anomaly number 10 seals the pattern. Loeb's analysis is measured, but you can sense the weight in his words. The fact that 3I/Atlas appears bluer than the Sun is extremely surprising. In other words, it shouldn't exist. If sunlight were the only heating source, it would shine redder, cooler, not hotter and bluer. The temperature gradient is flipped, defying every model. The only explanation left is an internal mechanism producing photons at higher energy than the radiation it receives. Behind closed doors, scientists debated whether to publish this probability analysis, because when you multiply the odds of each anomaly, the result is staggering. Ecliptic alignment, 0.2%. Sunward jet, less than 1%. Mass velocity paradox, a few percent. Perfect planetary timing, fractions of a percent. Factory-grade metal composition, virtually zero. Unique polarization signature, off the charts. WOW signal correlation, beyond astronomical. Blue-hot luminosity, thermodynamically impossible. Multiply them together and you get odds of less than 1 in 10 quadrillion. That's worse than winning 15 lotteries in a row or being struck by lightning twice in a year while holding a royal flush you didn't deal. At that point, Occam's razor flips. The simplest explanation is no longer a weird rock. The simplest explanation is intent. If Loeb's right, 3I/Atlas may be running on technology capable of sustaining temperatures hotter than the Sun, implying mastery over fusion, antimatter, or something even more exotic. And civilizations capable of that kind of power, they don't just wander in by accident. Every anomaly, its timing, trajectory, brightness, and impossible composition point toward one conclusion: purpose. Right now, observatories around the globe are listening, microphones turned to the stars, waiting to catch even the faintest whisper from the cold blue traveler that shouldn't exist, but does. Something extraordinary is unfolding behind closed doors, and for once, even Congress is paying attention. In an unprecedented move, several congressional members are pushing for the release of classified, high-resolution images of 3I/Atlas captured on October 2nd, now being shared with top scientific institutions across the world. Researchers are combing through the data, pixel by pixel, searching for any sign of intelligent design. Course corrections, faint radio pulses, artificial light modulation, even the ghostly warmth of propulsion systems in infrared. The instruments are live, the sensors are humming, and for the first time in human history, every data stream from deep space is flowing openly. And that's when the countdown begins. In just 30 seconds,
you'll understand why December 19th is shaping up to be the most important date of this decade, maybe even this century. 3I Atlas is re-emerging from behind the sun. The world's telescopes are waking up. In mere days, twilight skies will once again reveal its blue shimmer to ground observers. On December 19th, 2025, it will make its closest approach to Earth. And when it does, every major eye we have in space will be watching. The Hubble Space Telescope, the James Webb, and dozens of brown-based arrays will lock onto a single target. One enigmatic traveler whose very existence challenges the laws of physics. Scientists know exactly what's at stake. If 3I Atlas maneuvers, if it emits structured, non-random signals or displays symmetry inconsistent with natural breakage, humanity will, for the first time, have proof, undeniable proof of alien engineering. But if, against all odds, natural processes can explain its 10 impossible anomalies, then our understanding of the universe must be rewritten from the ground up. Either way, the outcome changes everything. This isn't about deciphering ancient relics or chasing echoes from the void. We're witnessing it live, a cosmic mystery unfolding in real time, an object glowing with energy that surpasses our own star. As you read this, spacecraft instruments are already repositioning, locking into observation windows across the solar system. Avi Loeb and research teams on 6 continents are poring over spectral data, counting photons, cross-referencing wavelengths, and watching every flicker for meaning. 50 days. That's all that separates us from the closest encounter. 50 days to decide whether we are alone or not. This isn't history you'll find in a textbook or buried in archives. It's streaming now, second by second across coronagraphs, radio dishes, and data feeds tracking an impossible visitor hurtling towards us. Whether 3I Atlas turns out to be the strangest comet ever born or a machine powered by physics that outpaces our sun, one truth remains inescapable. Nothing natural should glow blue at perihelion. And yet, something does. Soon, very soon, we'll see what technology beyond our star really looks like when it drifts within reach of human instruments. 50 days to find out if we've ever truly been alone in the cosmos. 50 days until history writes itself, not in ink, but in light.